What would it mean for a single galaxy to grow so large that its light takes millions of years just to cross from one side to the other? When astronomers look out into the universe, they do not see neat islands of stars floating alone in darkness. They see vast, luminous systems whose edges fade gradually, where stars thin into gas, gas blends into halos, and structure gives way to gravity's quiet reach. A galaxy does not end the way a planet ends. There is no sharp boundary, only a slow falling away of matter, until the night between galaxies begins to dominate. Even our own Milky Way, which feels immense from within, is defined not by a wall of stars, but by how far its gravity can still hold on. If you find yourself enjoying this kind of quiet exploration, you are warmly invited to like and subscribe, so these moments of shared curiosity can continue. And if you feel like it, let me know where you are listening from. Perhaps a city, a room, or a quiet stretch of night, somewhere on this small planet inside one ordinary galaxy. For a long time, astronomers believed galaxies had natural limits. Gravity pulls matter together, but motion and energy push back, and early observations suggested a balance that produced galaxies of roughly similar scale. Spiral galaxies formed graceful disks. Elliptical galaxies gathered stars into dense, rounded clouds. Beyond a certain size, it seemed, galaxies simply could not remain coherent. Their stars would drift away, and the structure would dissolve into the surrounding universe. That expectation came from what we could see. Telescopes revealed the bright cores and glowing arms, and measurements stopped where the light grew faint. Because light was our guide, light defined our imagination. If stars mark the edge, then stars must be the edge. This idea felt stable because it matched what the sky appeared to show, and for decades, nothing obvious contradicted it. But as instruments improved, astronomers began to notice something unsettling. In the deep surveys of the modern universe, certain galaxies appeared embedded in enormous, diffuse regions of light, stretching far beyond familiar scales. Their stars were sparse, almost whispering against the darkness, but they were real. These systems did not fit comfortably within the old boundaries. They were not just slightly larger, they were immense, spreading across distances once thought impossible for a single galaxy to hold together. What made these galaxies especially striking was their environment. They were not alone. They lived at the crowded centers of galaxy clusters, places where hundreds or even thousands of galaxies drift together under shared gravity. In such regions, motion slows, encounters become frequent, and gravity has time to work patiently. Over billions of years, smaller galaxies wandered too close, their stars pulled free, their structures stretched and absorbed, adding faint layers to the growing giant at the center. This growth does not happen in a sudden act of violence. It is more like accumulation through quiet persistence. A galaxy passes nearby. Its outer stars loosen, and those stars do not return. Over immense spans of time, this process repeats again and again, until the central galaxy becomes surrounded by an enormous, ghostly envelope. The visible core remains recognizable, but the true galaxy has become something far larger and more diffuse than earlier generations of astronomers ever imagined. And still, even this visible growth is only part of the story, because light traces only a fraction of what a galaxy truly is. Beyond the faintest stars lies a vast halo of dark matter, invisible yet dominant, shaping the galaxy's gravity and defining its real extent. This halo can stretch far beyond the visible light, binding stars, gas, and even neighboring galaxies into a single massive structure. When astronomers measure the largest galaxies today, they are measuring not just starlight, but the eye reach of gravity itself, extending across millions of light years. In this way, the discovery of the largest known galaxies did not simply expand a number in a catalog. It expanded the very meaning of a galaxy. These giants are not anomalies that break the universe's rules. They are the natural result of time, gravity, and environment working together with extraordinary patience. They remind us that the universe often grows not through dramatic moments, but through slow, inevitable accumulation, unfolding quietly across cosmic time. When astronomers finally realized how large galaxies could become, one particular object began to quietly stand apart. At the center of a distant galaxy cluster known as Abell 2261, there lies a galaxy that does not immediately announce its enormity through brightness or dramatic shape. Instead, its size reveals itself slowly, through careful measurement and patience, much like the galaxy itself must have grown. At first glance, this galaxy looks almost understated. Its core is broad and calm, lacking sharp features, as if the stars there have long since settled into a stable arrangement. But as astronomers traced the faint light surrounding it, they noticed something unusual. The starlight did not fall off where they expected. It kept going, thinning almost imperceptibly, spreading farther and farther into space. What initially seemed like background glow turned out to be part of the galaxy itself. Stars still bound by gravity, still belonging. To understand just how large this system was, astronomers had to combine several kinds of observation. Optical telescopes mapped the faint outer stars. Infrared surveys helped separate those stars from more distant galaxies behind them. X-ray observations revealed the hot gas filling the surrounding cluster, tracing the gravitational well in which the galaxy sits. Each method added a layer, like overlapping transparencies, slowly clarifying the full structure. What emerged was astonishing. This single galaxy extends across more than 6 million light-years. To picture that, imagine light leaving one edge of the galaxy and traveling, uninterrupted, for 6 million years before reaching the other side. During that entire time, continents on Earth would shift, species would rise and fall, and human history would remain unimaginably far in the future. And yet, all of that distance remains held together by one gravitational identity. An analogy helps here, briefly and carefully. Think of a calm lake at night, where the deepest water is invisible from the shore. You might see only the ripples near the edge, but the lake extends far beneath the surface, shaped by contours you cannot directly observe. In the same way, the brightest part of this galaxy is only the visible surface of something vastly deeper and wider, defined by gravity rather than light. What makes this galaxy especially revealing is not just its size, but how naturally it fits into what we now understand about cosmic growth. It sits at the center of its cluster, exactly where gravity would funnel matter over billions of years. Smaller galaxies drift inward, their stars slowly stripped and added to the outer regions. The cluster itself acts like a reservoir, supplying material not all at once, but gradually, patiently, without urgency. This is how astronomers know this size is real. The stars move as though they belong. The gas behaves as if it is bound. The dark matter halo inferred from gravitational effects extends smoothly outward, enclosing the entire structure. Nothing about the system suggests an accident or illusion. It behaves exactly as a single, enormous galaxy should. And in recognizing this, something subtle changes in our understanding. The universe did not suddenly produce a monster galaxy that breaks the rules. Instead, it followed the same rules it always has, simply allowing them to operate for longer in denser environments with fewer interruptions. Size in the universe is often just time made visible. For a long time, models of galaxy formation were built around moderation. They assumed that growth would slow as galaxies became large, that energetic processes near their centers would heat surrounding gas and prevent endless accumulation. In these models, gravity pulled inward, but feedback pushed outward, creating a kind of cosmic self-regulation that kept galaxies within a predictable range of sizes. The existence of these enormous galaxies forces a careful reconsideration of that balance, not because the models were wrong, but because they were incomplete. In the dense cores of galaxy clusters, conditions are different. Gas is already hot and widespread. Motions are slower. Encounters are frequent. In these environments, growth does not rely on fresh gas forming new stars, but on something quieter and more persistent: the gradual rearrangement of existing matter. This leads to an important shift in perspective. These giant galaxies are not growing by bursting into life again and again. They are growing by inheritance. Stars formed long ago in smaller galaxies are gently reassigned, redistributed into a larger gravitational home. The result is expansion without brightness, size without spectacle. From a distance, the galaxy does not look dramatically different, but in reality it has become something vast. Because of this, astronomers have had to rethink what it means to model a galaxy at all. It is no longer enough to simulate isolated systems forming in empty space. The largest galaxies only make sense when their environment is included, when clusters are treated as living ecosystems rather than mere collections of parts. Growth becomes a collective process, shaped by shared gravity over immense spans of time. This realization also softens an earlier assumption that galaxies are mostly finished once their stars are formed. Instead, structure continues to evolve long after star formation slows. Shape, size, and extent remain flexible, slowly adapting to their surroundings. A galaxy can become enormous not by doing more, but by lasting longer in the right place. What these giants ultimately teach us is restraint. The universe does not rush to its extremes. It allows them to emerge quietly, where conditions permit, through accumulation so gradual that it almost escapes notice. Our theories are not overturned by this, but gently stretched, much like the galaxies themselves, expanding to include a universe that is more patient and more spacious than we once assumed. What makes these enormous galaxies truly difficult to grasp is not only their size, but the time required to create them. Nothing in the universe builds something this large quickly. Every layer of stars in the outer regions represents events spread across billions of years, long before Earth formed, long before the Milky Way took its current shape. When astronomers reconstruct the history of these galaxies, they find no single era of dramatic growth. Instead, there's a steady accumulation stretched across most of cosmic time. Small galaxies fall inward, not in a rush, but gradually, guided by the deep gravitational pull of the cluster. Each encounter contributes only a thin veil of stars, barely noticeable on its own. But time allows those contributions to stack, one after another until size becomes inevitable. This slow pace is essential. If everything happened faster, the system would be chaotic and unstable. Instead, the universe gives gravity room to work gently. Orbits relax. Stars settle. The galaxy remains coherent even as it expands, because nothing forces it to change abruptly. Stability is not the absence of motion, but motion spread thinly over immense time. Seen this way, these galaxies become records rather than objects. Their extended halos are archives of past structures, stars that once belonged elsewhere, now tracing elongated paths around a shared center. Each star carries a quiet history of displacement, yet together they form something remarkably calm. Immensity here is not violent, it is composed. This teaches us something subtle about cosmic evolution. The universe favors processes that can survive for long durations. Structures that grow slowly tend to endure. The largest galaxies are not the most energetic or efficient. They are the most patient, shaped by conditions that allow gravity to act without interruption for billions of years. And this patience is written into the universe itself. From the first galaxies forming after the early universe cooled, to the sprawling giants we observe today, structure emerges not through urgency, but through persistence. Size becomes a consequence of time allowed to pass without resistance. Main topic: how can a single galaxy grow to sizes that stretch across millions of light years? Current subtopic: what the existence of such enormous galaxies implies about the future growth of galaxies, including our own. When we turn this understanding toward the future, the implications become quietly personal. Our own Milky Way is not destined to remain exactly as it is. Over billions of years, it will continue to interact, merge, and exchange stars with its neighbors. The upcoming encounter with the Andromeda Galaxy is only one step in a much longer story. If the Milky Way were to find itself at the center of a dense cluster, its fate could be very different. Over enough time, it too could develop a vast, faint envelope of stars, extending far beyond its familiar spiral arms. Not because it suddenly changed character, but because gravity kept working while time remained abundant. These giant galaxies remind us that nothing in the universe is final on human timescales. What seems fixed is often just slow. What appears complete is often still unfolding. Galaxies grow not toward an endpoint, but toward equilibrium with their surroundings, adjusting gently as the universe ages. In this sense, the largest galaxies are not exceptions. They are previews of what is possible when gravity is given enough time and space to operate without interruption. They show us that the universe builds its grandest structures, not through spectacle, but through endurance. And perhaps that is the most expansive idea of all, that immensity does not require urgency, that complexity can arise from patience, that the universe, at its largest scales, reveals itself not by rushing forward, but by allowing itself to grow, quietly, into what it has always been capable of becoming. When we step back even further, these enormous galaxies begin to look less like individual objects and more like junctions in the universe's architecture. They sit where invisible filaments of matter intersect, where gravity has been quietly directing motion since the universe was young. Long before any stars existed, these regions were already marked by slightly higher density, subtle imbalances left over from the early universe that would later determine where matter preferred to gather. Over time, gas flowed along these filaments, cooling and condensing, forming the first galaxies. Those galaxies then moved along the same gravitational pathways, drawn toward the deepest wells. The largest galaxies we see today are not random outcomes. They are the natural consequence of this long guidance, shaped by patterns laid down billions of years before light ever filled the cosmos. In this way, the size of a galaxy becomes a visible echo of the universe's earliest structure. The faint stars stretching across millions of light years are tracing paths determined long ago, responding to gravity that has never stopped acting, never needed to hurry. What looks like excess is actually alignment, matter simply following the shape of space-time itself. This perspective changes how we think about scale. A galaxy is no longer just a collection of stars. It is a memory of motion, a record of where matter has been allowed to go. Its vastness reflects not ambition but permission. Permission granted by the surrounding universe to keep growing, to keep gathering, to remain at the center of a slow, converging flow. And as we notice this, something quietly grounding emerges. The universe does not build its largest structures through force or intention. It builds them through consistency. Gravity behaves the same everywhere. Time moves forward without preference. Where conditions allow both to act together for long enough, immensity follows naturally. These galaxies are not trying to be large. They simply never had a reason to stop. Trying to picture a galaxy that spans millions of light years gently disrupts the way distance usually feels. Inside such a structure, separation loses its sharp edge. Two stars may be farther apart than any journey we can meaningfully imagine, yet they still belong to the same system, still responding to the same deep gravitational presence. In the universe, belonging is not defined by closeness, but by influence. Within these vast galaxies, stars follow orbits that take hundreds of millions of years to complete. Their motion is slow, almost ceremonial. Nothing rushes. A star can spend eons drifting through the outer halo, so far from the bright center that the galaxy's core is just a faint glow in its sky, and yet it remains gently bound, never fully leaving. Membership here is quiet and patient, maintained not by force, but by consistency. This challenges an instinctive idea we often carry without noticing, the idea that size implies cohesion through tightness. On Earth, things stay together because they are close. In space, things stay together because gravity has had enough time to weave a shared history. These galaxies are not compact communities. They are extended conversations, still ongoing, still responding to the same underlying structure of space-time. There is also something humbling in realizing how loosely the universe defines identity. A galaxy can be so large that light itself takes millions of years to cross it, and yet it is still considered one object. Meanwhile, from our perspective, entire civilizations rise and fall in the time it takes a single star in the outer halo to noticeably change its path. Scale reshapes meaning. Seen this way, the largest galaxies gently invite a shift in perspective. They suggest that unity does not require density, and continuity does not require speed. Things can be spread out, slow and faint, and still be part of something whole. The universe seems comfortable with this kind of spacious belonging, allowing structures to exist that feel almost more like regions than objects. And perhaps that is the quiet lesson embedded in their size. That connection can persist across immense distances. That coherence can be subtle. That even in a universe defined by expansion and vast emptiness, gravity is able to create identities that stretch farther than imagination, without ever needing to pull tightly at all. Trying to hold the full scale of these galaxies in mind requires letting go of familiar anchors. Human intuition is shaped by landscapes where distances are crossed in minutes or hours, where boundaries are visible, where belonging is confirmed by nearness. A galaxy that stretches for millions of light years asks for a different kind of understanding, one that is less about picture and more about a process. Inside such a galaxy, motion unfolds so slowly that change almost disappears. Stars do not sweep across the sky, they drift. Over thousands of human lifetimes, their positions barely shift. Even over millions of years, the change is subtle, a gentle rearrangement rather than a journey. This slowness is not emptiness. It is stability stretched thin across time. Gravity is what makes this possible, not as a pulling force that drags everything inward, but as a quiet rule that shapes motion everywhere at once. Each star feels only a faint tug, but that tug never stops. Over immense durations, even the weakest influence becomes decisive. This is how galaxies remain whole without being tight, coherent without being compact. In the outer reaches of these giant galaxies, the night sky would look profoundly different from anything we know. The dense band of stars that defines our view of the Milky Way would be absent. Instead, stars would appear scattered, isolated, set against vast darkness. The galaxy would not feel like a city of light, but like a sparse archipelago. And yet, despite appearances, everything would still belong to the same system. This contrast reveals something important. Appearance is not a reliable guide to structure in the universe. Brightness draws attention, but gravity defines reality. The most influential parts of a galaxy are often invisible, made of dark matter that neither emits nor absorbs light. It is this unseen framework that allows such enormous systems to exist at all, holding together stars that may never see one another. Dark matter halos do not have edges in the way objects do. Their density gradually decreases with distance, fading into the surrounding universe without a clear boundary. This makes the idea of where a galaxy ends less like a line and more like a gradient. Membership becomes a matter of degree rather than a yes or no. A star is part of the galaxy because it moves as part of the galaxy, because its future is shaped by the same gravitational field. This idea of belonging through motion rather than location changes how scale feels. A galaxy is not a thing you stand inside. It is a pattern you participate in. Even at immense distances from the center, stars trace paths that reflect the whole. Their orbits carry information about mass distributed far away, about encounters that happened billions of years earlier, about structures they will never directly encounter. Time is the thread that ties all of this together. Without long durations, these patterns could not exist. Gravity needs patience. It works best when nothing interrupts it. In the dense, turbulent early universe, structures formed quickly but crudely. As the universe expanded and cooled, conditions softened, motions slowed, paths stabilized. The largest galaxies emerged not from early chaos, but from late calm. This tells us something quietly profound about cosmic evolution. The universe does not simply move from simple to complex. It moves from loud to quiet. Early eras were energetic, crowded, full of collisions and rapid change. Later eras allow refinement. Structures become more extended, more delicate, more diffuse, but also more stable. Immensity is a feature of maturity. These giant galaxies are therefore not youthful achievements. They are elderly structures shaped by long memory. Their stars come from many origins, many smaller systems that no longer exist as independent entities. What remains is not a patchwork, but a smooth continuum, because time has erased the seams. Motion has mixed everything, thoroughly. In this sense, the largest galaxies are less like buildings and more like landscapes. They are not assembled according to a plan. They are eroded, layered, and reshaped by slow forces acting consistently. Their size is not a statement. It is a consequence. Thinking this way also reframes how we imagine our place in the universe. From within a galaxy, especially one as large as these, it would be almost impossible to intuit the full structure. Local motion would feel ordinary. The sky would change slowly. There would be no sign from daily observation that one was part of something millions of light years across. Knowledge of that scale would come only from careful measurement and shared understanding. This mirrors our own situation. We do not feel Earth moving through space, or the Milky Way rotating, or the local group drifting through the cosmic web. These motions are real, but their timescales are so large that experience alone cannot reveal them. Understanding comes from patience, from extending perception beyond instinct. The largest galaxies remind us that reality is often operating far outside the range of immediate sensation. They encourage a form of curiosity that is not driven by spectacle, but by quiet consistency. Nothing about these systems demands attention. Their significance emerges only when we look carefully, measure precisely, and allow our intuition to stretch. There is also a subtle shift in how time feels when considering these scales. Human history becomes a thin slice, almost negligible. Entire civilizations fit into the blink of a star's orbital motion. This is not diminishing, it is contextual. It places human activity inside a much larger continuity, one that is not hostile or indifferent, but simply vast. These galaxies do not exist in spite of expansion. They exist because of it. As the universe grows larger, structures have more room to spread out, more time to relax. Expansion creates the space in which gravity can draw wide, gentle arcs rather than tight spirals. Immensity becomes compatible with stability, and still growth continues. Even now, these galaxies are not finished. Stars are still being added at the margins. Motions are still adjusting. Boundaries are still softening. The universe does not rush toward completion. It allows its structures to keep unfolding, slower and quieter as time goes on. This slow unfolding suggests a different relationship between size and significance. The largest things are not the most intense. They are the most persistent. They do not dominate through force, but through endurance. Their presence is steady rather than overwhelming. Sitting with this idea, the imagination begins to adjust. A galaxy millions of light years across stops feeling excessive. It starts to feel appropriate. Given enough time, given enough consistency, why would gravity stop early? Why would structure remain small if nothing requires it to? The universe does not seem to favor minimalism. It favors continuity. Where processes can continue without disruption, they do. Where motion can remain bound, it does. The largest galaxies are simply places where nothing got in the way for a very long time. And in that realization, scale becomes less intimidating. Immensity is no longer something to be impressed by. It becomes something to understand. A natural outcome of simple rules applied patiently, without exception, across a universe willing to wait. The existence of galaxies this large quietly reshapes how the future of the universe feels. Not in a dramatic sense, but in a structural one. If gravity has already assembled systems that stretch across millions of light years, then the universe has clearly not exhausted its capacity for organization. Expansion does not erase structure. It changes the way structure grows. As the universe continues to expand, distances between galaxy clusters will increase, but inside those clusters, gravity will remain dominant. Motion will slow further. Encounters will become rarer but also gentler. The largest galaxies will continue to accumulate matter at their outskirts, not through sudden events, but through gradual settling. Growth will not stop. It will simply become quieter. This suggests a future universe that is more diffuse, yet more internally stable. The brightest phases of star formation will fade. Galaxies will grow dimmer as new stars become scarce. But structure itself will persist. The great halos of the dark matter will remain, holding on to their stars long after the universe's most energetic eras have passed. In that far future, the largest galaxies may become the dominant visible structures left. Not because they outcompeted others, but because they endured. Smaller galaxies will merge or disperse. Isolated systems will drift beyond one another's reach. What remains bound will be what was already deeply embedded in gravity's slowest, strongest wells. This casts the largest galaxies, not as anomalies of the present, but as previews of what lasts. They show which structures are robust against time. They hint at what the universe preserves when everything energetic has had the time to run down. There is something unexpectedly calming in that picture. The universe does not collapse into chaos as it ages. It simplifies. Motion becomes less frantic. Structures spread out, but those that remain connected do so gently without strain. The future is not empty, it is spacious. Thinking about galaxies on these scales also reframes how beginnings and endings relate. The same gravity that assembled the first stars continues to shape the largest structures trillions of years later. There is no sharp boundary between early and late, between formation and evolution. It is one continuous process, thinning and slowing, but never stopping. This continuity answers the central question in an unexpected way. A galaxy can grow to unimaginable size, not because it does something extraordinary, but because the universe allows ordinary processes to keep operating for a very long time. Size is not a special achievement. It is duration made visible. That idea quietly resolves the tension between imagination and reality. What feels too large to be plausible often turns out to be perfectly natural once time is included honestly. Millions of light years sound excessive only when compared to human scales. Compared to billions of years, they are modest. The largest galaxies remind us that intuition is scale-dependent. What seems stable at one scale may be fleeting at another. What feels immense in one context may be inevitable in another. Physics does not privilege any particular viewpoint. It allows structures to grow wherever rules are followed, and nothing intervenes. This is perhaps why these galaxies feel so strangely gentle despite their size. They are not sculpted by rare conditions or fragile balances. They are built from the same gravity that shapes every orbit and every fall. The difference is not in the rule, but in how long it was allowed to act uninterrupted. In that sense, these galaxies are not telling us that the universe is extreme. They are telling us that it is consistent. It applies the same laws everywhere, patiently, without adjustment for scale. The result, given enough time, is immensity. Returning to the original question, how a single galaxy can grow so large, the answer now feels less mysterious. It grows the way coastlines erode, the way sediments settle, the way orbits relax. Slowly enough that no single moment defines the change. Steadily enough that the change becomes undeniable. This perspective also softens the boundary between knowing and feeling. Understanding these galaxies does not require awe as a reaction. It invites calm recognition. This is what happens when gravity and time are left alone together. And perhaps that is the most grounding realization of all. The universe is not rushing toward complexity or collapse. It is allowing itself to unfold, layer by layer, scale by scale, according to simple rules applied without interruption. The largest galaxies are not exceptions to that process. They are its most patient expressions. They show us that imagination does not fail because the universe is too big. It fails only when time is left out. Add time back in, honestly and fully, and even the largest structures begin to feel not just possible, but expected. Nothing about these galaxies asks to be marveled at. They do not demand wonder. They quietly earn it, simply by continuing to exist, continuing to grow, continuing to hold together across distances that once seemed impossible, but now feel like a natural consequence of a universe that knows how to wait. At a certain point, the question of size stops asking for numbers and starts asking for perspective. Millions of light years are difficult to picture, not because they are abstract, but because they belong to a regime where cause and effect unfold so slowly that intuition loses its grip. The universe does not signal these scales with drama. It reveals them through consistency. A galaxy this large is not experienced as large from within. Local space still feels quiet. Stars still rise and set. Motion still follows gentle arcs. Nothing announces that the structure extends so far beyond immediate surroundings. The enormity exists as a property of connection, not sensation. It is known through understanding, not through experience. This distinction matters. Much of human intuition relies on direct feedback. We trust what we can see change. We trust what responds quickly. But the universe operates comfortably outside those limits. Its most durable structures are the ones that change least noticeably. The largest galaxies belong to this category. They are not active in any dramatic sense. They are settled. Settled does not mean static. It means that forces are balanced over long timescales. Motion continues, but it is distributed so widely that no single region dominates. Energy spreads out. Differences soften. Over time, what remains is a broad, shallow structure that resists disruption precisely because it is so extended. This is one reason these galaxies can persist while smaller, denser systems may not. Compact structures are efficient, but they are also fragile. They concentrate energy, which makes them dynamic, but also makes them vulnerable. Large, diffuse systems dissipate disturbances. A passing galaxy, a burst of energy, a shift in motion affects only a small fraction of the whole. Scale becomes a form of resilience. Seen this way, the largest galaxies are not extreme objects at the edge of possibility. They are conservative outcomes. They represent what happens when nothing interrupts gravity for a very long time. No sudden collapse, no violent dispersal, just steady accumulation and gradual relaxation. This reframes the role of imagination. The difficulty in imagining such galaxies is not a failure of the universe to make sense. It is a mismatch between human timescales and cosmic ones. The universe does not operate at the pace we evolved to track. It has no need to. Once this is accepted, the idea of a galaxy millions of light years across stops feeling extravagant. It begins to feel proportional. Given billions of years, given repeated interactions, given gravity acting everywhere at once, why would growth stop early? What mechanism would enforce smallness indefinitely? There is none. Instead, the universe allows structures to expand until they encounter resistance. In the emptiest regions, expansion dominates. In dense regions, gravity wins. The largest galaxies simply occupy the places where gravity has remained unchallenged for the longest time. Their size is a record of that uninterrupted dominance. This perspective also clarifies why such galaxies are rare. They require very specific conditions: a dense environment, long stability, minimal disruption. Most regions of the universe do not provide this combination. Many galaxies grow, merge, and then are scattered or isolated. Only a few remain at the center of everything long enough to accumulate so extensively. Rarity, in this case, does not imply exceptionality in the laws of physics. It implies rarity in circumstance. The rules are universal. The outcomes depend on where and how long they are allowed to operate. Understanding this removes a subtle tension that often appears in discussions of cosmic extremes. The largest galaxy does not challenge the universe's coherence. It reinforces it. It shows that the same principles apply smoothly from the smallest bound systems to the largest ones we can observe. There is no sudden jump where new rules appear. There is no special scale where physics changes character. The universe is remarkably unwilling to introduce surprises at boundaries. It prefers continuity. This continuity extends to us. The atoms in the human body follow the same rules as the stars in the outer halo of a giant galaxy. The difference is not in the physics. It is in the time scale and the number of participants. Everything else is shared. That realization quietly narrows the gap between the familiar and the immense. The universe does not reserve its deepest coherence for distant objects. It expresses it everywhere, at every scale, all the time. The largest galaxies simply give us a clearer view of what patience produces. There is also an emotional shift that can happen here, though it arises directly from the science rather than sitting beside it. If the universe builds its most enduring structures slowly and without urgency, then speed and intensity are not prerequisites for significance. Persistence matters more. These galaxies did not win a race. They stayed in place. Their growth required no foresight, no complexity, no planning. It required only that gravity remain allowed to act, uninterrupted, for long enough. That simplicity is not reductive. It is stabilizing. Returning again to the central question, how a single galaxy can become larger than imagination, the answer now feels almost disarmingly simple. It becomes large the way any system becomes large when nothing forces it to stop. Imagination struggles because it is accustomed to interruptions. The universe, in these regions, experienced very few. This also explains why such galaxies do not feel threatening or overwhelming despite their size. They are not active agents. They are settled configurations. They do not impose themselves. They persist. Even the word biggest begins to lose some of its weight here. Largest compared to what? To human experience, to earlier observations, to expectations shaped by limited data. In the broader context of cosmic time, size is fluid. Structures grow, relax, merge, and disperse. Nothing is permanently maximal. The largest galaxy we know today will not hold that title forever. Either something larger will be found, or time will continue to reshape what exists. Records in the universe are provisional. The laws are the only constants. This understanding brings the focus back to observation itself. Every extension of telescope sensitivity, every deeper survey, gently expands what we consider plausible. The universe has not changed. Our ability to notice it has. The discovery of galaxies this large is not a revelation about the universe suddenly behaving differently. It is a revelation about how incomplete earlier pictures were. Light was faint. Hollows were invisible. Boundaries were assumed. As instruments improved, assumptions softened. And with that softening came calm. The universe did not break open into chaos. It became smoother, larger, more continuous. That smoothness is perhaps the most important takeaway. The universe is not stitched together from discrete objects separated by hard edges. It is a gradient of structure, with density slowly rising and falling, with membership defined by motion and influence rather than borders. The largest galaxies embody this better than anything else we know. They are not isolated islands. They are centers of extended regions, places where structure thickens gradually rather than abruptly. Their vastness reflects the universe's preference for continuity over compartmentalization. Sitting with this, imagination begins to adjust its expectations. Size stops being something to resist or question. It becomes something to accept as a natural outcome of time applied consistently. The universe does not aim for moderation. It aims for equilibrium. Where equilibrium allows immensity, immensity appears. And so the biggest galaxies we have discovered are not reminders of how small we are or how wild the universe can be. They are reminders of how steady it is, how willing it is to let simple rules play out fully, without interruption, without urgency, across scales that quietly exceed what intuition was built to hold. In that steadiness, there is a sense of reliability. The universe is not improvising. It is repeating itself patiently at every scale. The largest galaxies are simply the places where repetition had the most time to accumulate. Nothing about them asks us to be astonished. They invite something gentler, recognition, understanding, a quiet recalibration of what feels normal once time is allowed to be as large as space. There is a moment where immensity stops expanding outward and begins to settle inward, not as an image, but as an understanding. A galaxy millions of light years across no longer feels like something that must be visualized all at once. It becomes something that can be trusted to exist without being held fully in mind. The universe does not require us to picture it correctly in order for it to be real. It only requires that the rules remain consistent. Gravity does not check whether a structure feels intuitive before shaping it. Time does not compress itself to match human attention. They simply continue, and structures arise accordingly. At this scale, the idea of control disappears entirely. No region of a giant galaxy governs the rest. There is no command center, no privileged location where the system decides what to become. Everything follows the same local rules, responding only to nearby influences, and yet a coherent whole emerges across distances so large that light itself takes millions of years to connect them. This coherence without central direction is one of the most quietly powerful lessons these galaxies offer. Order does not require oversight. Structure does not require intention. Given enough time, even simple interactions can produce systems that feel impossibly large and yet remarkably stable. This is not emergence in the dramatic sense. Nothing new suddenly appears. It is emergence through accumulation, through repetition, through small effects that never cancel out because nothing interrupts them. In the outermost regions of these galaxies, gravity is extraordinarily weak. A star there is only faintly bound. Its future is not dramatically constrained. It could drift outward and eventually escape, or remain loosely tethered for trillions of years. Both outcomes are allowed. What matters is that the time scale is long enough for either to feel almost irrelevant. This softness at the edges is not a flaw. It is what allows the system to be so large. Hard boundaries would fracture. Sharp edges would destabilize. A gradual fade allows flexibility. It allows the galaxy to absorb change rather than resist it. The universe seems to favor this design. Wherever structures endure, they do so by being tolerant. They allow variation. They distribute stress. They avoid rigid definitions. The largest galaxies embody this principle at the grandest scale we know. Even the concept of an edge becomes optional. Astronomers can define boundaries for measurement, but the galaxy itself does not recognize them. Stars do not know when they have crossed a line. Dark matter does not terminate abruptly. Everything tapers, softens, and blends into the surrounding cosmic environment. This blending is important. These galaxies are not separate from the universe around them. They are continuous with it. Their outer regions overlap with the intracluster medium, with streams of gas, with diffuse populations of stars that may belong partly to one system and partly to another. Identity is shared, negotiated, and sometimes ambiguous. Ambiguity is not a problem here. It is a feature. The universe does not insist on clean categories. It allows overlap, gradients, and transitions. The largest galaxies are where this preference becomes most visible, and because of that, they offer a gentler way of thinking about scale itself. Instead of imagining size as something that demands attention, it can be understood as something that emerges naturally when conditions allow continuity. This perspective also alters how discovery feels. Finding a galaxy larger than expected is not a shock in the sense of contradiction. It is a recalibration. It tells us that earlier measurements were incomplete, not that the universe has changed its behavior. Each time our instruments improve, boundaries move outward. Faint light becomes detectable. Subtle motions become measurable. What once looked empty reveals structure. This process has repeated itself throughout the history of astronomy, and these galaxies are simply the latest example. There is a quiet humility in that pattern. The universe keeps offering more, not because it is becoming more, but because we are learning how to notice what was already there. The largest galaxies were not created by observation. They were revealed by patience. That same patience is required to truly absorb what they mean. These are not objects that reward quick fascination. They ask for sustained attention, for willingness to let understanding unfold slowly. In that sense, they are perfectly aligned with the way the universe itself operates. Nothing about them is urgent. Nothing about them is optimized for immediate impact. They are vast because nothing ever forced them to stop being vast. This absence of forcing is key. Many cosmic structures are shaped by disruption. Supernovae explode. Galaxies collide violently. Black holes release immense energy. These events are important, but they are not what built the largest galaxies. those were built in the quieter intervals, in the long stretches between disruptions where gravity could act without competition. Silence, in cosmic terms, is productive. Over billions of years, silence allows matter to settle into wide orbits. It allows energy to dissipate. It allows systems to relax into configurations that are difficult to disturb. The largest galaxies are monuments to uninterrupted quiet. This idea gently counters a common assumption that the most significant things in the universe must also be the most energetic. In reality, energy is fleeting. It flares and fades. What remains is what had time to stabilize. The universe seems to agree with this. As it ages, it becomes less energetic overall, but more structured at large scales. Small, bright events give way to large, dim ones. Activity gives way to persistence. The largest galaxies sit at this intersection. They are dimmer per unit volume than smaller galaxies. Their stars are spread thin. Their light is faint. And yet, taken as a whole, they are among the most massive structures ever assembled. Mass without brightness. Influence without spectacle. This again reshapes intuition. It suggests that importance does not correlate with intensity. A system can matter profoundly without ever announcing itself loudly. The universe is comfortable with understatement, and perhaps this is why these galaxies feel strangely calming to consider. They do not confront us. They do not overwhelm. They simply exist, extended and steady, asking nothing of our attention beyond understanding. As this understanding settles, the central question begins to loosen its grip. How can a galaxy become so large? It becomes clear that the question was never about possibility. It was about expectation. Expectation was shaped by limited data, by brighter objects, by shorter timescales. Once those limits are removed, the answer becomes almost inevitable. A galaxy grows large because nothing prevents it from doing so. This inevitability does not strip the universe of wonder. It refines it. Wonder shifts from surprise to recognition, from spectacle to coherence. The universe reveals itself not by breaking its own rules, but by applying them thoroughly. And in that thoroughness, imagination is not defeated. It is trained. Slowly, gently, it learns to accommodate scales that once felt excessive. It learns that patience is a legitimate force. That continuity can produce outcomes more dramatic than any single event. The largest galaxies do not stretch imagination because they are unreasonable. They stretch it because imagination evolved for interruption, while the universe rewards endurance. Once this is accepted, the tension resolves. Immensity stops feeling like an outlier. It becomes a natural expression of a universe that has had a very long time to do what it always does. Gravity gathers. Time allows. Structure accumulates. Nothing more is required. And so the biggest galaxies we have discovered are not statements about excess. They are statements about allowance, about what happens when simple rules are given freedom to operate without interference. They do not shout their existence. They whisper it across millions of light years, through faint stars and gentle motions, through a coherence that holds without strain. Understanding them does not require awe as a reaction. It invites something quieter. Trust. Trust that the universe is not arbitrary. Trust that its largest creations are not accidents, but consequences. Consequences of patience. Consequences of consistency. Consequences of a universe that never rushes, and therefore has no reason to stop. There is a quiet shift that happens once immensity no longer feels like a challenge to comprehension. The universe stops appearing as something that constantly exceeds us and begins to feel like something that simply operates on a different rhythm. The largest galaxies belong to that rhythm. They do not confront understanding, they wait for it. At this point, the idea of a galaxy millions of light years across no longer asks to be pictured as a single object. It can be held instead as a condition where gravity has remained dominant for long enough, a condition where motion has slowed rather than accelerated, a condition where change accumulates so gradually that it becomes structure. This way of thinking dissolves the urge to find a dramatic cause. There was no moment when a galaxy suddenly became enormous. No threshold crossed. No switch flipped. Growth happened below the level of notice, the way erosion reshapes landscapes without ever announcing itself. Only the outcome reveals the process. This is one reason these galaxies feel so different from the way extremes are often imagined. They are not sharp, they are not intense, they are broad, diffuse, and almost reluctant to stand out. Their significance lies not in contrast, but in continuity. Continuity is the universe's preferred mode. From the earliest density fluctuations after the hot beginning, through the formation of atoms, stars, and galaxies, the same pattern repeats. Small differences are allowed to persist. Over time, persistence turns difference into structure. No intervention is required. The largest galaxies simply occupy the longest-running examples of this process. They are where the universe had the fewest interruptions, where gravity could act without being reset, dispersed, or overwhelmed by expansion, where the slow accumulation of matter was allowed to remain coherent. This sheds light on something subtle about cosmic order. Stability does not require stasis. These galaxies are not frozen, they are active in the quietest possible way. Stars move, halos breathe, orbits adjust, but all of it happens slowly enough that nothing fractures. Slowness becomes strength. In human systems, slowness is often associated with inefficiency. In cosmic systems, slowness is what allows complexity to persist. Rapid change introduces stress. Slow change allows adaptation. The largest galaxies embody adaptation stretched across billions of years. Even their internal diversity reflects this. The stars within them did not form together. They came from many places, many eras, many smaller galaxies that no longer exist. And yet, over time, their motions have blended into a smooth distribution. Differences remain, but they are no longer disruptive. This smoothing is not homogenization, it is integration. Individual histories are not erased, they are layered. The galaxy becomes a composite of countless pasts, each contributing a small fraction to a larger whole. Seen from this perspective, a galaxy is less an object than a process that has not yet finished. Its present form is a snapshot of motion midstream, not a final state. The largest galaxies simply represent the longest snapshots we have access to. This has implications for how we think about knowledge itself. Much of what feels counterintuitive about these galaxies comes from the way imagination expects completion. We look for edges, endpoints, final forms. The universe rarely provides them. Instead, it offers systems in motion, temporarily stabilized, always subject to further change. Even the largest galaxies will not remain as they are forever. Over unimaginable spans of time, stars will fade, orbits will decay, and gravitational bindings will weaken as expansion continues to stretch space itself. But that future dissolution does not make the present structure any less real. Transience does not negate coherence. The universe is comfortable with things that last a long time without lasting forever. This comfort is written into its laws. Gravity has no preference for permanence. It simply responds to mass and distance. Time has no endpoint. It simply proceeds. Together, they generate structures that endure as long as conditions allow. The largest galaxies show us what endurance looks like at cosmic scale. Not resistance, not rigidity. Endurance through flexibility, through gradual change, through wide distribution. This again softens the emotional response these galaxies evoke. They are not monuments. They are equilibria. They are not achievements. They are outcomes. And yet, understanding them deepens a sense of connection rather than diminishing it. The same principles that shape these immense systems shape every orbit, every fall, every accumulation of matter. There is no privileged scale where physics suddenly becomes unfamiliar. There is only unfamiliar duration. This realization quietly reframes humanity's place in the universe, not as something small confronted by something vast, but as something brief situated within something long. The difference is not magnitude alone. It is time scale. Human experience is dense. Events happen quickly. Feedback is immediate. Change is obvious. The universe operates sparsely. Events are spread thin. Feedback takes millions of years. Change must be inferred. Neither mode is superior. They simply occupy different regimes of the same laws. The largest galaxies remind us that meaning does not require immediacy. Significance does not require speed. A system can matter deeply even if nothing about it happens quickly enough to notice in a lifetime. This perspective has a quiet grounding effect. It removes the pressure to extract drama from scale. The universe does not need to be exciting to be profound. It does not need to astonish to be coherent. These galaxies do not overwhelm. They reassure. They reassure us that complexity can arise without chaos, that order can emerge without control, that stability can persist without rigidity, that growth does not require urgency. Even the idea of being bigger than imagination begins to soften here. Imagination struggles not because the universe is excessive, but because imagination evolved for survival, not for billion-year processes. Once imagination is allowed to rest in understanding rather than imagery, the strain eases. Understanding does not require visualizing every detail. It requires trusting the logic of cause and effect. Given gravity, given time, given an environment where neither is disrupted, the result follows. This trust is earned through consistency. Every observation of these galaxies aligns with the same explanation. Their stars move as expected. Their mass distributions behave as predicted. Their environments support their growth. There are no exceptions demanding special treatment. The universe remains elegant even at its extremes. Elegance here does not mean simplicity in appearance. It means simplicity in rule. The same gravity that binds a planet to a star binds stars to galaxies and galaxies to clusters. The difference is scale and patience. Patience emerges again as the central theme, not as an abstract value, but as a physical condition. Where patience exists, structures grow. Where impatience is imposed by rapid change or disruption, structures remain small or fragile. The largest galaxies are physical embodiments of patience. Not intentional patience, but the absence of disturbance, the allowance of continuity. This idea carries an unexpected calm. It suggests that the universe is not competing with itself. It is not racing toward outcomes. It is allowing outcomes to develop where conditions permit. That allowance extends everywhere. Even now, new structures are forming quietly in the universe. Not spectacular ones, but subtle rearrangements. Streams of stars extending, halos relaxing, orbits smoothing. Nothing announces these changes. They simply happen. The biggest galaxies we have discovered are not the end of that process. They are midpoints. Large ones, but not final ones. Our observations are still limited. Our sensitivity is still improving. Boundaries may yet move outward again, and if they do, it will not mean that the universe has changed character. It will mean that we have learned once more how much room it has always allowed itself. This learning follows a familiar pattern. Expectation meets observation. Observation extends understanding. Understanding adjusts expectation. Calm follows coherence. At the beginning, the idea of a galaxy millions of light years across feels unreasonable. At the end, it feels almost conservative. Given what the universe has had time to do, why would it stop earlier? This is not resignation. It is alignment. Alignment between intuition and reality. Between imagination and law. Between scale and time. The universe does not ask to be admired for being large. It asks to be understood for being consistent. The largest galaxies are not statements of excess. They are confirmations of reliability. Reliability across unimaginable distances. Reliability across unimaginable durations. That reliability is what allows understanding to rest. Nothing about these galaxies is fragile. Nothing about them is forced. They exist because the universe allowed them to. And in that allowance, something quiet becomes clear. Immensity is not a challenge to meaning. It is meaning extended across time. The universe does not hurry, and so it has room to become vast. It does not insist, and so it becomes stable. It does not interrupt itself, and so structure accumulates. The biggest galaxies are simply what happens when nothing gets in the way. And once that is seen, imagination no longer needs to stretch. It can settle, because the universe, at its largest scales, is not asking us to keep up. It is simply continuing, patiently, exactly as it always has. As the idea settles further, the universe begins to feel less like a collection of extraordinary cases, and more like a place governed by deep, steady habits. The largest galaxies no longer appear as curiosities perched at the edge of understanding. They feel like natural resting points in a long sequence of events that has never been hurried. Gravity gathers, time allows, and structure follows. Nothing more elaborate is required. Inside this understanding, the word biggest quietly loses its tension. It no longer implies competition or excess. It simply marks a point along a continuum. Larger than what we once expected, yes, but not larger than what the universe itself is prepared to accommodate. The universe has never shown an inclination to economize on scale. Where space exists and time flows, patterns are free to extend. This freedom is easy to overlook because it operates below the threshold of immediate change. Human experience is shaped by thresholds. We notice beginnings and endings, sudden shifts, moments where one state gives way to another. Cosmic structure rarely behaves this way. It changes continuously, so gradually that no single moment defines the transition. Only when we compare distant epochs does the transformation become visible. The largest galaxies are records of that comparison. They show us what happens when we look not for moments, but for trends. When we stop asking what caused something to happen all at once and start asking what was allowed to keep happening without interruption. In that frame, size becomes a memory rather than a surprise. Memory is an appropriate word here, because these galaxies retain the imprint of countless past interactions. Each faint star in their outer regions carries a history that predates its current home. Long ago, it belonged to a smaller system, orbiting a different center, responding to a different local balance of forces. Over time, that system was drawn in, stretched, and gently dissolved, its stars reassigned without violence. The memory remains not as a story, but as motion, as orbit, as distribution. This is how the universe preserves information, not through narrative, but through structure. The largest galaxies are dense with information, even though they are diffuse in matter. Their shapes encode their histories. Their motions reveal their pasts. Nothing is erased, only blended. Blending is a slow process. It requires that nothing disrupt it. In regions where the universe is turbulent, where energy is injected frequently, where motion is chaotic, blending cannot complete. Structures remain sharp, smaller, more distinct. In calm regions, blending proceeds. Boundaries soften. Systems grow large by becoming less defined. This again points to a subtle truth. Sharpness and scale are often opposed. The universe trades one for the other. Small systems can be sharply defined. Large systems tend to be gentle, graded, and expansive. The largest galaxies accept this trade willingly. They give up brightness per unit volume, give up clear edges in exchange for endurance and reach. Once this is understood, immensity no longer feels like a violation of order. It feels like an expression of it. The universe is not cluttered with contradictions. It is layered with outcomes that differ only in degree, not in principle. That realization also changes how future discoveries are anticipated. If a galaxy larger than those currently known were to be identified, it would not require a new explanation. It would simply extend the same one. Another region where gravity remained dominant. Another environment where time was allowed to pass undisturbed. Another confirmation that scale is limited not by law, but by circumstance. Circumstance, in cosmic terms, is everything. The universe does not select outcomes deliberately. It allows them where conditions align. Dense clusters create opportunities for growth. Isolation limits it. Energy injection accelerates change. Calm permits accumulation. The largest galaxies are outcomes of alignment, not intention. This understanding carries a quiet emotional effect. It removes urgency from scale. The universe is not racing toward larger and larger structures. It is allowing structures to find their natural extent. That extent varies. Some remain small, some grow large. None are trying to become anything else. There is a kind of neutrality in this that can feel unexpectedly reassuring. The universe is not striving. It is not optimizing. It is not escalating. It is proceeding. Proceeding is a gentle word, but it captures the essence of cosmic evolution better than more dramatic alternatives. Things proceed according to the same relationships they always have. Mass curves spacetime. Curved spacetime guides motion. Motion redistributes mass. Over time, patterns emerge. Nothing in this process is hurried. Nothing demands attention. The universe does not perform for observers. It simply continues to be consistent, whether or not it is being watched. The largest galaxies in this sense are not landmarks meant to impress. They are byproducts of consistency. Their vastness is an incidental outcome of uninterrupted rule-following. As this perspective deepens, imagination stops resisting scale and begins to reorganize around it. Instead of trying to compress millions of light-years into a mental image, understanding relaxes into abstraction grounded in cause and effect. A galaxy is large because gravity acted for a long time. That statement becomes sufficient. Sufficiency is important here. Not everything needs to be pictured to be understood. Some truths are structural rather than visual. They are held by logic, not by imagery. The universe operates comfortably in that mode, even if human minds often prefer pictures. When imagination shifts in this way, scale becomes less emotionally charged. It no longer provokes awe as a reflex. It invites contemplation as a state. The difference is subtle but important. Awe flares and fades. Contemplation settles and stays. The largest galaxies reward contemplation. They do not offer quick payoff. Their significance emerges slowly, through repeated consideration, through letting go of assumptions about how big is too big, how long is too long, how diffuse is too diffuse. These assumptions tend to come from environments where resources are limited, where change is rapid, where interruption is common. The universe, at its largest scales, is none of those things. Space is abundant. Time is extensive. Interruption is rare. Once that mismatch is acknowledged, the feeling of excess disappears. The universe is not extravagant relative to itself. It is only extravagant relative to minds shaped by scarcity. Scarcity does not apply at cosmic scale. Energy may thin, matter may spread, but space and time remain generous. The universe has no reason to constrain itself to smallness. This generosity is not chaotic. It is structured. Even as space expands, gravity still gathers where it can. Even as energy dissipates, mass still curves space-time. Order persists not by resisting change, but by accommodating it. The largest galaxies show this accommodation in action. They do not oppose expansion. They coexist with it. Their internal motions slow, their structures relax, their boundaries soften, but their identity persists as long as binding remains. Identity here is not sharp. It is statistical. A star belongs to the galaxy because its motion aligns with the system as a whole. If that alignment weakens over time, belonging fades. Nothing dramatic happens at the moment of departure. The universe does not mark the occasion. This lack of ceremony is characteristic. Cosmic processes do not announce transitions. They simply proceed. Only later, when differences accumulate, do those transitions become apparent. Understanding this further reduces the urge to locate turning points. The growth of the largest galaxies did not hinge on decisive events. It hinged on absence of disruption, on long stretches where nothing dramatic happened. Nothing happened, and so everything accumulated. That phrase captures the heart of it. In the universe, absence of disturbance is productive. Quiet is not empty. It is permissive. It allows weak forces to integrate their effects over time. Gravity is the weakest of the fundamental forces, yet it dominates the large-scale structure of the universe precisely because it never turns off and never cancels out. Given enough time, it shapes everything. The largest galaxies are gravity's long-term projects. This does not romanticize gravity. It simply acknowledges its nature. It pulls gently, relentlessly, impartially. It does not care about scale. It applies the same rule everywhere. Once that is accepted, the size of the largest galaxies no longer needs to be justified. It is exactly what gravity does when given enough opportunity. Opportunity, in this context, means time without competition. In dense clusters, gravity outweighs expansion locally. Motions slow. Encounters accumulate. Growth continues. Elsewhere, expansion wins and structures remain isolated or disperse. Both outcomes follow the same laws. The universe does not choose between them. It allows both. This allowance extends to our understanding as well. There is room to hold both familiarity and vastness without forcing one to dominate the other. The universe does not require that everything be relatable to human scale. It also does not require that humans be excluded from understanding larger scales. Understanding happens when expectation adjusts, when imagination stops insisting on immediacy, when time is allowed to be long. At that point, the idea of a galaxy larger than imagination becomes less about limitation and more about recalibration. Imagination does not fail. It learns to operate differently. It learns to trust explanation over picture, process over snapshot, continuity over event. The universe rewards that trust. Once imagination aligns with process, scale stops being a problem. A galaxy millions of light years across is no longer something to strain against. It is something that fits naturally into a story that began long before any observer existed and will continue long after. That story has no climax, no conclusion. It does not build toward an endpoint. It unfolds. The largest galaxies are not endings. They are chapters written slowly, with no urgency, no deadline, no need to resolve. They exist because the universe had room to let them exist. And in that realization, something settles. The universe is not trying to outpace understanding. It is not escalating complexity to stay ahead of comprehension. It is doing what it always does, at every scale, with unchanging patience. Gravity gathers, time allows, structure accumulates. Once that rhythm is felt, there is no longer any need to chase the idea of bigger. Bigger is simply what happens when the rhythm continues uninterrupted. The biggest galaxies are not beyond imagination. They are beyond impatience. And once impatience is released, imagination does not need to stretch any further. It can rest comfortably inside a universe that has always been willing to wait. As this rhythm becomes familiar, another subtle understanding begins to take shape. The universe does not distinguish between what is finished and what is ongoing in the way human thinking often does. Structures are never truly complete. They are simply in phases where change is slow enough to feel like rest. The largest galaxies occupy one of these long resting phases, extended moments where gravity and motion have reached a temporary balance that can last for billions of years. Rest, here, does not mean inactivity. It means that opposing influences have softened into coexistence. Expansion pulls space outward. Gravity curves it inward. Neither wins entirely. The result is a wide equilibrium, one that allows structures to persist without tightening or dispersing too quickly. This equilibrium is not fragile. It is broad, forgiving, and resilient precisely because it is not extreme in any one direction. In this light, the size of the largest galaxies becomes a measure of balance rather than excess. They are not places where gravity overwhelmed everything else. They are places where gravity remained relevant for a very long time without being destabilized. Their vastness reflects moderation sustained over duration, not domination. Duration is the quiet variable that reshapes almost every cosmic question once it is taken seriously. Many ideas that feel implausible at first glance become almost inevitable once billions of years are allowed to accumulate their effect. The universe is not built from dramatic moments stacked end to end. It is built from gentle influences applied relentlessly. This relentlessness is not forceful. It is consistent. Gravity does not surge. It does not rest. It applies the same influence at every moment. Over short spans, its effects can seem negligible. Over long spans, they become defining. The largest galaxies are reminders that patience is not passive. It is active across time. There is a temptation to imagine that something must be holding these enormous systems together with particular strength, some hidden mechanism beyond what we already know. But observation offers no such requirement. The motions of stars, the distributions of mass, the shapes of halos all align with the same physics observed at smaller scales. Nothing new is invoked. Nothing extra is needed. This simplicity is easy to underestimate because it lacks drama. But simplicity applied thoroughly is powerful. The universe does not need complex instructions to produce complexity. It needs only consistency and time. Time, in turn, does not care about human relevance. It does not speed up for interest or slow down for clarity. It simply proceeds. In doing so, it allows weak effects to become dominant, subtle trends to become structure, faint accumulations to become immense systems. The largest galaxies are not monuments to excess energy. They are monuments to uninterrupted time. Thinking this way changes the emotional tone of scale entirely. Immensity no longer feels intimidating. It feels earned. It feels like the natural result of letting something continue long enough to reveal its full capacity. There is also a gentle reassurance in realizing that nothing about these galaxies is precarious. They do not teeter on the edge of collapse. Their size does not make them unstable. On the contrary, their diffuseness makes them robust. Disturbances pass through them like ripples through a vast body of water, noticeable locally, irrelevant globally. This robustness arises from distribution. Mass spread over large volumes responds less violently to change. Energy injected in one region dissipates before it can reorganize the whole. Large systems absorb shocks by dilution. Thus, largest galaxies exemplify this principle at cosmic scale. Once this is understood, it becomes clear why such galaxies are difficult to disrupt and equally difficult to assemble. Both processes require time. Assembly requires long periods of calm. Disruption requires sustained disturbance. Neither happens quickly. This slow dynamic contrasts sharply with the way attention often works. Attention is drawn to sudden change, to brightness, to movement. The largest galaxies offer none of these. They are faint, slow, and steady. They do not demand notice. They reward patience. Patience, in this context, is not a moral quality. It is a physical condition. Where processes are allowed to unfold without interruption, outcomes emerge that cannot be rushed into existence. The universe operates comfortably in this mode. It is worth noticing how often misunderstanding arises when time is compressed. Questions like how something could become so large often carry an implicit assumption that growth must be rapid to be real. But rapid growth is rarely stable. The universe favors growth that survives, not growth that impresses. Survival requires accommodation. Accommodation requires space and time. The largest galaxies had both. This understanding also reframes how beginnings are imagined. The early universe was not arranged to produce giant galaxies as a goal. It simply set initial conditions and allowed laws to operate. Over time, those laws produced a range of outcomes. The largest galaxies are one end of that range, not a target. This absence of targeting is important. It removes any sense that the universe is building toward extremes for their own sake. Extremes appear naturally where distributions are broad and time is long. They are statistical outcomes, not ambitions. Once that is clear, surprise softens into recognition. The universe is not surprising us. It is revealing what was always implied by its rules. This realization gently dissolves the final tension between imagination and reality. Imagination struggles when it tries to substitute for understanding, when it insists on imagery where process would suffice. Once imagination is allowed to rest on explanation, scale becomes manageable. A galaxy millions of light-years across does not need to be pictured in detail. It needs to be understood as the result of gravity operating without interruption across vast spans of time. That understanding is stable. It does not flicker or fade. It does not require constant reinforcement. In this stability, there is a quiet satisfaction. The universe is not withholding comprehension. It is offering it patiently through consistency. The largest galaxies do not break the universe open into mystery. They close a loop. They show that the same principles apply everywhere, from the smallest bound systems to the largest ones we can observe. That closure is not final. It does not end inquiry. It grounds it. It allows further questions to arise without destabilizing what is already understood. Questions about what lies beyond the faintest edges, about how long binding can persist in an expanding universe, about how structure fades rather than ends. These questions emerge naturally once the foundation feels secure. Security in understanding does not eliminate curiosity. It deepens it. It allows curiosity to move outward rather than sideways, forward rather than scattered. The largest galaxies, by being so steady, make this possible. They anchor understanding. They show that even at the grandest scales, the universe remains coherent. This coherence is not imposed, it is emergent. It arises because the laws are simple enough to be applied everywhere and stable enough to remain unchanged over time. Gravity does not weaken with age. Time does not alter its own direction. Expansion does not erase binding where binding is strong enough locally. These consistencies allow structure to persist even as the universe evolves. The largest galaxies exist at the intersection of these consistencies. They are not anomalies, they are confirmations. And so the idea of something being bigger than imagination finally settles into something else entirely. It becomes a statement not about limitation, but about adaptation. Imagination, once freed from the demand to compress, adapts to a universe that operates patiently. Patience becomes the bridge between scale and understanding. The universe does not rush to show itself. It unfolds at its own pace. The largest galaxies are not messages sent to us. They are consequences left behind. Consequences of gravity applied without interruption. Consequences of time allowed to pass without urgency. Consequences of a universe that does not seek moderation or excess, but simply follows its rules wherever they lead. Once this is accepted, there is no longer a need to push further. Understanding does not require reaching a boundary. It requires settling into coherence. The biggest galaxies we have discovered do not ask to be chased or surpassed. They ask to be understood for what they are. They are what happens when nothing gets in the way for a very long time. And in that understanding, there is room to rest. As this sense of rest takes hold, the universe begins to feel less like a sequence of questions demanding answers, and more like a pattern that can be quietly observed without pressure to resolve it. The largest galaxies no longer sit at the end of curiosity. They settle into the background as part of the universe's normal behavior, as ordinary in their own way as gravity itself. At this stage, understanding no longer depends on adding new concepts. It depends on letting earlier ones fully integrate. Gravity does not need reinforcement. Time does not need elaboration. Their interaction, once truly absorbed, explains more than any additional mechanism could. The universe becomes simpler as understanding deepens, not more complex. There is a temptation, especially when dealing with extremes, to search for hidden causes, to assume that something so large must be the result of something special. But the universe repeatedly resists this narrative. Its most expansive structures arise not from rare conditions, but from common ones applied patiently. What is rare is not the rule, but the uninterrupted opportunity. Opportunity, in cosmic terms, is shaped by environment. Dense regions provide shelter from expansion. Calm regions allow motion to slow. Over time, these environments nurture growth not through intensity, but through continuity. The largest galaxies are children of such environments, shaped not by force but by protection from disruption. This protection is subtle. Nothing shields these galaxies in an active sense. They are not enclosed or isolated. They simply occupy regions where competing influences cancel gently enough to leave gravity room to operate. Expansion pulls outward. Surrounding mass pulls inward. The balance creates space for accumulation. Balance here is not static. It shifts slowly, adjusting as mass redistributes and orbits evolve. But these shifts occur over such long spans that they feel like permanence. The universe does not freeze its structures. It slows them until change becomes almost imperceptible. In this slowed state, structure acquires a different quality. It is no longer defined by formation, but by persistence. The largest galaxies are not actively forming in the way young galaxies do. They are maintaining shape, maintaining binding, maintaining coherence across distances that once felt impossible. Maintenance is not often celebrated, but it is essential. Without it, structure dissolves. The universe invests heavily in maintenance, not by allocating resources, but by allowing time to do the work. Over time, unstable configurations fade, while stable ones remain. What we observe today is filtered by this long selection. The largest galaxies are survivors of that filtering. They are configurations that have proven resilient against countless minor disturbances. Each small encounter that failed to disrupt them instead contributed to their growth, adding mass, extending halos, smoothing distributions. This smoothing is crucial. Roughness invites instability. Smooth distributions distribute stress. Over time, galaxies that smooth their mass distributions become harder to disturb. Size and smoothness reinforce one another. As galaxies grow larger, they grow calmer. Calmness at cosmic scale is not emptiness. It is organization without urgency, motion without friction, change without drama. The largest galaxies are calm because their internal dynamics are spread so thinly across space that nothing accelerates quickly. This thinness also explains why such galaxies are difficult to detect. Their light is faint. Their stars are sparse. They do not announce themselves through brightness. They must be revealed through careful measurement, through patience that mirrors their own formation. Discovery, in this context, becomes a partnership between observer and universe. The universe offers faint signals. Observation responds by extending sensitivity. As sensitivity improves, structure appears, not suddenly, but gradually, like an image developing in slow exposure. Each improvement in observation does not reveal something fundamentally new. It reveals something that was always present but previously below the threshold of notice. The largest galaxies are not surprises. They are confirmations that thresholds have moved. This movement of thresholds is an important part of the story. It reminds us that understanding is not limited by what exists, but by what can be detected. As tools improve, understanding expands, not by overturning old ideas, but by extending them. Extension is the dominant theme again. The universe extends. Our reach extends. Understanding extends. Nothing breaks, nothing resets, everything continues. This continuity is what allows calm to emerge naturally from comprehension. There is no need to dramatize scale when it fits smoothly into a framework that already works. The universe is not asking for astonishment. It is offering coherence. Coherence, once felt, changes the emotional relationship to size. Immensity stops feeling alien. It becomes familiar in principle, even if not in detail. The universe begins to feel less like an adversary to intuition and more like a teacher of patience. Patience, here, is not about waiting for answers. It is about allowing understanding to arrive without forcing it into forms it does not naturally take. The universe does not compress itself for clarity. It unfolds at its own pace. Once this is accepted, curiosity relaxes. It no longer pushes against scale. It flows with it. Questions become gentler. How did this come to be becomes how did this continue? Continuance is the key. The largest galaxies exist because nothing stopped them. This is not a lack of explanation. It is the explanation. In a universe where laws are consistent and time is abundant, stopping becomes the unusual event. Disruption, not growth, requires explanation. Growth, under the right conditions, is the default. This reversal of expectation is subtle but powerful. It shifts focus from asking why something is large to asking why something is small. Smallness becomes the outcome of interruption, of isolation, of energetic disturbance. The largest galaxies, then, are not excessive. They are uninterrupted. Understanding this also brings a sense of proportion to other cosmic scales. Planetary systems, star clusters, even galaxies like our own appear as different expressions of the same rules operating under different conditions. None are privileged. None are diminished. They simply occupy different regions of parameter space. Parameter space is an abstract phrase, but its meaning is simple. Change the density. Change the environment. Change the available time. Outcomes adjust accordingly. The universe explores this space freely. The largest galaxies occupy the corner where density was sufficient, time was long, and disturbance was minimal. That corner exists naturally. The universe had no reason not to explore it. Once this is clear, imagination no longer needs to be coaxed forward. It follows naturally. A galaxy millions of light years across feels no more strange than an ocean thousands of kilometers wide. Both are outcomes of accumulation under persistent forces. Water flows downhill. Gravity pulls inward. Given enough time and space, Both produce expanses that dwarf immediate experience. Neither requires special explanation. This analogy need not be extended. Its purpose is simply to remind that scale itself is not mysterious. It is the product of persistence. Persistence is the universe's most reliable behavior. It does not tire. It does not change course. It does not require motivation. It applies its rules consistently and allows outcomes to emerge. The largest galaxies are records of that persistence, written not in words, but in motion and mass. Reading those records does not require awe. It requires attention. Attention to how faint stars move, to how halos curve space, to how distributions extend smoothly outward without abrupt ends. Attention reveals that nothing about these systems is precarious. They are relaxed. They are settled. They are not straining to hold together. They are comfortable at their scale. Comfort is an unusual word in cosmology, but it applies here. These galaxies are not resisting their own size. They are not on the verge of dispersal. They are simply large because they can be. This ability to be without strain is another form of stability. Stability does not require rigidity. It requires accommodation. The largest galaxies accommodate change by being spacious. Spaciousness, again, becomes a virtue rather than an excess. It allows systems to absorb variation without losing coherence. It allows time to act without conflict. The universe seems to prefer this arrangement. As it ages, its structures become larger, dimmer, and more diffuse. Energy concentrates early, then spreads. Matter clumps early, then relaxes. The largest galaxies sit within this long arc. They are not early achievements. They are late outcomes. They belong to a universe that has had time to soften. Softness here does not imply weakness. It implies resilience. Hard systems break. Soft systems bend. The largest galaxies bend so gradually that breaking becomes unlikely. This resilience extends their lifetimes. They will persist long after smaller, more energetic systems have faded or transformed. In the far future, they may be among the last visible structures left, faint but enduring. This does not grant them special status. It simply reflects the consequences of scale. Large, diffuse systems evolve slowly. Small, compact systems evolve quickly. Understanding this places everything on a continuum. There are no abrupt categories, only gradients of size, density, and timescale. Once gradients replace categories, anxiety about extremes dissolves. The largest galaxies are not exceptions to be explained away. They are endpoints of gradients that begin with much smaller structures. Endpoints, however, are never final. They are simply the furthest along the gradient we have observed so far. This open-endedness keeps curiosity alive without urgency. There is no pressure to reach a final understanding. The universe does not close itself off with conclusions. It allows understanding to grow the same way structure does. Gradually, without interruption. In this sense, the process of understanding mirrors the process it seeks to explain. Knowledge accumulates faintly at the edges, extending outward as sensitivity improves. There are no sudden revelations, only steady expansion. This parallel is not poetic, it is structural. Both the universe and our understanding of it operate through accumulation. The largest galaxies are reminders of this shared process. They do not demand reverence. They invite alignment. Alignment with time. Alignment with patience. Alignment with the idea that not everything needs to resolve quickly to be real or meaningful. Meaning, like structure, can be diffuse and enduring. It does not need to be concentrated to matter. The universe, at its largest scales, seems comfortable with that idea. It builds meaning slowly, through persistence rather than intensity. The biggest galaxies we have discovered embody that comfort. They are not spectacular, they are not dramatic, they are simply extensive. And in their extensiveness, they show that imagination does not need to stretch endlessly to keep up with the universe. It only needs to slow down. Once it does, the universe stops feeling overwhelming and starts feeling reliable. Reliable enough to rest inside. Because nothing about these galaxies suggests urgency. Nothing about them suggests excess. They exist because the universe gave them time, and time in the universe is generous. As this understanding settles more fully, the universe begins to feel internally consistent in a way that no longer asks to be justified over and over again. The largest galaxies no longer sit at the edge of explanation, waiting for a final piece to make them make sense. They feel like the natural outcome of a universe that has never been in a hurry, a universe whose most powerful shaping force is not energy or violence, but endurance. Gravity does not need to be strong in the dramatic sense to be decisive. It only needs to be persistent, acting quietly at every moment, adding its influence infinitesimally, never retreating, never pausing. Over short spans, this persistence is invisible. Over billions of years, it becomes architecture. This is why the largest galaxies do not feel engineered. They feel worn in, like landscapes shaped by erosion rather than structures assembled by design. Their size is the accumulated trace of everything that did not interrupt them. Each small galaxy that drifted too close, each star stripped gently from its original home, each orbit that slowly widened rather than destabilized, contributed without ever announcing its contribution. Nothing needed to happen all at once. Nothing needed to be decisive. The universe simply kept allowing motion to settle into deeper and wider patterns. This is what makes these galaxies so difficult to reconcile with intuition built on urgency. Human intuition expects thresholds, tipping points, moments where a system suddenly becomes something else. Cosmic structure rarely works that way. Change is distributed so evenly across time that no single moment can be identified as the cause. Only the result reveals the process, and by then, the process has already passed beyond easy reconstruction. In that sense, these galaxies are not puzzles to be solved, but outcomes to be recognized. Recognition does not demand excitement. It invites acceptance. The universe is not trying to impress with scale. It is demonstrating what happens when simple rules are never suspended. Once this is truly absorbed, the question of how a galaxy can grow larger than imagination begins to dissolve rather than resolve. It dissolves because imagination itself adjusts its expectations. It stops trying to compress the universe into moments and starts allowing it to exist across durations. A galaxy millions of light years across no longer needs to be imagined in detail. It can be understood as a region where gravity has been relevant long enough to matter everywhere at once. That understanding is stable. It does not flicker or strain. It rests comfortably inside the same framework that explains orbits, tides, and the slow settling of matter into disks and halos. Nothing new is required. No exception is made. The universe remains uniform in its behavior even when its outcomes appear extreme. This uniformity is what ultimately brings calm. There is no hidden mechanism waiting to surprise us at large scales. There is no dramatic shift where familiar physics gives way to something unknowable. The same gravity that guides a falling object on Earth guides stars at the edge of a galaxy cluster. The difference is not in kind, but in patience. Patience allows weak effects to accumulate. Patience allows structure to become vast without becoming fragile. Patience allows the universe to build things that feel almost excessive only because we are not used to thinking in spans long enough to accommodate them. Once patience is restored to the picture, excess disappears. Everything feels proportionate again. The largest galaxies are not outsized relative to the universe that contains them. They are appropriately sized for a cosmos that has been expanding, cooling, and settling for billions of years. They fit. And because they fit, they do not demand awe as a reaction. They invite trust. Trust that the universe is coherent at every scale. Trust that understanding does not collapse when distances grow large. Trust that time, when allowed to be long, explains more than complexity ever could. In that trust, imagination no longer needs to keep pushing forward. It can settle into a slower rhythm, one that matches the universe more closely. The universe does not sprint. It does not escalate. It accumulates. The biggest galaxies we have discovered are not monuments to ambition or power. They are monuments to allowance. They exist because nothing forced them to stop becoming what they were already in the process of becoming. And once that is seen clearly, there is no further tension to resolve. The universe feels neither overwhelming nor distant. It feels steady. It feels patient. It feels like something that can be understood not by grasping harder, but by letting go of the need for immediacy. Gravity gathers. Time allows, structure remains. Nothing about this needs to be dramatic to be true. And so the question gently releases its hold, not because it has been forced into an answer, but because it no longer needs to be held tightly at all. A galaxy larger than imagination turns out not to be a challenge to understanding, but an invitation to let understanding adopt a different pace. The universe is not asking to be grasped quickly or contained neatly. It is offering itself as something that unfolds reliably when given time. The largest galaxies we have discovered are not spectacles meant to astonish. They are confirmations that the universe is patient, consistent, and willing to let simple rules express themselves fully. Gravity does not hurry, and so it has time to gather. Time does not conclude, and so structure is allowed to persist. Nothing about this process strains the universe. Nothing about it demands urgency. These galaxies exist because the universe never insisted they stop. And in noticing that, there is a quiet settling, a sense that immensity does not need to overwhelm in order to be, real that scale does not need to impress in order to matter. The universe reveals itself not through drama, but through continuity, and once that continuity is felt, there is nothing left to resolve. Only something steady to rest within, knowing that the same patience shaping galaxies across millions of light years is the patience that carries everything forward, calmly, without end.